Hello everyone, this is Judge Jawhar. Today I'm going to tell you more about the hand scanner, how to use it, and what's the different modes that can be used in it. So basically we have two modes, the SV and the GL. The SV mode can be used for the parts that are less than 1 meter in size, and then the GL mode, which stands for the photogrammetric mode, can be used for parts that are larger than 1 meter. Uh, so how now I'm going to show you how to start using the scanner. First, of course, we need to do the connections. You can find the scanner inside its case, safely stored in there. You can take it out, place it somewhere safe, and start doing the connections. You can find one free end cable coming from the adapter. That one should be attached just right in here, and then there are these two ports should be placed just inside the scanner. This one is like this. You will find an arrow on this rounded port. The arrow should point upwards, and then it will be firmed sticked inside the scanner, and then you will search for this USB port, and this one will go just inside the laptop. After that, after you do all the connections, the last step is connected it to the electricity, the last step. So don't try to plug it in the socket before doing the connections. The electricity should be lost. And then you can see here on the screen, this is the program, the software that we are going to use for this tutorial. Its name is X program. You can see here there is this SV mode and GL mode. In this tutorial I'm going to show you how to use this SV mode step by step. And so first we click on that. You can see in here the colors. So if the color is blue, it means that the scanner is connected to the software. If it is red, it means that it is not connected, and it will show a green color while scanning. And that's how you know that your scanner is actually connected, because sometimes the USB port will just like get loosened, and then the scanner will show red color, which means that you have to check your connections. Before we start scanning, we need to set these reference points. The reference point should be at least 2 millimeters away from the edge. We need to place reference points in a way that is enough for us to do the whole scanning. The scanner needs at least 4 reference points in a certain view in order to attach both scans together, both pictures together, and try not to put like extra ones, because each one of those costs money, and the less you use the better for us. But of course you need to do it in a way that is enough. And then we need to do the calibration. You can find the calibration panel just under this plate. You will find it in here, and then there are these scale bars. You can take them out while sliding them up, place them somewhere safe, and then take this calibration panel. You can see the arrow, it should always point upwards. You can place it somewhere, maybe on the floor or on this table, and grab your scanner, and you will see on the screen you can click this fast calibration button in order to start the calibration process. You can see it, I can show you in here, and then this one over here. You click that and you are ready to go. Then this one will pop up, and to start and stop you can press on this one. So we go just above the calibration panel, we click the start button, and then the scanner will start to work. The deeper you will see basically a square and a circle on your screen. The closer you go to the calibration panel, the smaller the circle will be, and the farther you go, the bigger the circle. And then you have to put the circle inside the circle, so like coincident. Basically you will have a circle that is shown on the screen, and then you need to go on a certain distance so that both circles coincide on the certain on one circle. And then with these sides viewing, and then this will affect the angle. For example, the circle would go either left, right, up or down, and then as you can see in here, and then now the calibration is done. And if you move forward or backward, and then the square will go like up or down, left or right. Now you can see that the calibration is done. You can click the close button and go back to the main screen. In here now we need to do the adjust the exposure. At first it will be 1 millimeter. We click on the adjust automatic exposure, and then this kind of yeah. And now with the same button we click to start. You just go around the part, and then this one will show you the new number, which is now in this case 0.35, and it will automatically change it in the settings, so you don't have to do anything manually. So after you click, I'll show you now in here, after you click that automatic exposure up there near that fast calibration, now you can see that the exposure has already been edited by itself. Now you can see that this part is a little bit shiny, it has some holes, so we need to edit some settings before we start. So in here you can see that there are some features, for example this deep holes, so that it can go deeply and scan deep holes. There's this one glaive, which means that if the part is a little bit reflective, and then it will be able to scan that. And there's this dark object, like for example if you have a dark object like black color, you know that the dark color will absorb light, and the scanner will basically relate into that reflected light and do all those calculations and do the scanning. So if you have a dark object, you have to click this dark object button in order to be able to scan it. And then we click that mark points and we click start. After that you can just take your scanner and you click again the same button to start. It will start scanning your mark points, and then you can see now that the light is green, which means that it is scanning, as you can see in here, which means that you are on the right distance from the part. If you go a little bit away, and then it will start beeping, and you can see that there is a red color going inside this blue ring. And then again also if you go like too close, again it will start beeping to warn you that you are like too close, so get a little bit far from there. Also you can see that on a scale bar, like in here you can see there is this green, yellow and red. The green means that you are inside the like you are on the right distance away from the part, and as you go like to the yellow, and then it will start beeping as you saw in the previous video. And then you can see here that it start taking all these mark points and put them all together. Once we are done, we can click stop. Yeah, so we click stop, and then we need to click this optimization button and then go to the setup. In the setup, we need to select 3 reference points that are on the surface, so that it will create a plane and the scanner won't scan anything below this plane. Otherwise it will scan the whole table. So basically I'll show you now. In the software, we need to find these 3 points. So after we click that optimization button, now we go to this setup button, and we need to find these 3 reference points that can create our plane. In here you can, like I can of course see from my part on the table, and these 3 points in here are the points that can create our plane. Just right here you can select those, and then you can set an offset distance. I usually put it for 0.1 millimeter, because then, for example, if there is a little bit dust on the table or I don't know, whatever, and then it won't scan those. So this 0.1 millimeter, it will be like above this table. It will now you can see that there is this you have like different colors, then you know like which points did you select. You can see that those are now white and the others like a little bit dimmed in color. And then we click this laser patch, and again with the same thing, we click start and go around the part. With this there is this menu bar, if basically button. If you press that, you can adjust the scale and do whatever by this plus and minus buttons, as well as there is an option where you can switch between a single laser or multi-laser scanning option. And how do you do that? By clicking the same button for stopping and starting the scanning process twice, and then you will switch between 2 modes. Now I'm scanning like the part and going around, and you can see on my screen that my part is getting done. I can click the stop button again once I feel that I'm done, and here I'll show you what was going on inside the software while I was working. By clicking this menu, I was able to zoom in and see and take a better look at our part and what's going on. And here you can see this single and multi-laser. The multi-laser of course is way faster, but sometimes you need the single laser option in case you need some details somewhere. Yeah, and once you feel your part is ready, now you can see that it is like scanning everything. You can see that there is still a little bit some parts that are not filled. That is because the part is a little bit shiny. We need to spray it, but in this case, because it is just for demonstration, I didn't spray it, and to show you what will happen if the part is shining. So in this case, you can see here there is still a little bit some gaps. There is also this like these mesh in here. You can just select them and delete them. Sometimes this software create them, I don't know why, but you can just delete them. And on the left side above this exposure, there is the resolution. The less the resolution, the better the quality. For example, if you have a small part, you have to put maybe the resolution around 0.2 to 0.3, but if you have a bigger part, you can just leave it at 0.5. Now you can see that the part is a little bit is still hollow from the other side. So what we need to do is to add a new scan and scan it from the other side, and then merge these two scans together in order to create one full scan. These all the settings are still the same. We don't need to do anything, not the we don't need to do calibration or the automatic exposure. We just go back to these mark points and click start, and yeah, after that we can start scanning our part by clicking these mark points and clicking start button. You flip it around. Of course, you need to put the mark points also from the other side in order to scan your part, and then you move around, try to get all those points, stop, and when you go back to the software, now I'll show you what was going on. You can see now the mark points are being scanned and gathered together into our software. When these mark points show this red color, it means that the scanner is like seeing those mark points right now. After that, we click stop, and we then need to click this optimization button before doing the setup. After that, we go to the setup, we select our 3 reference points, we select the offset distance 0.1 mm, and again go back to this laser patch, click start, and do the same process as before. Now with the same button, now I adjust the scale, I walk around and try to get the scan from every side. Yeah, and now I'll show you what was going on, how the part looks like. Here, when I adjust the scale, I can see better inside my software. I can know when I can stop, when I need to click the stop button. And now I'm just walking around, scanning the whole part, even from inside. It's good to have all the details because it will help you after that in the reverse engineering. After that, you click this stop, and now you can see our part. Again, we got these mesh flying in the air and then you need, of course, to delete those. You select them and you click delete from the keyboard to delete those. And if we go now to this data, now we have the scan 1 and scan 2. In here you can see like each one is from different direction, one from the top and the other from the bottom. Now we are going to attach these two together. We click the right mouse button, we set one as test and the other one as reference. I don't know, for some reason it was not showing here in the recording. And then you will go inside this. After clicking the splicing, you will see them both in that right side together. The first one is already selected. Now we are going to choose 3 reference points that are common between the two scans. So basically what are common is that those parts that are on the sides, because then the software by these reference points can attach these two scans together into one single part. Remember to tick this merge, because then it will just merge your part after you click the apply button. You can see now on that right side, yeah, that the part is already merged, and I click OK. But don't freak out, our part is not a hollow. You need to click on the second one and you can see that our part is fully scanned. And with this wrap, then we can convert our scanned file into STL. By clicking that, we can see here there are different options, like for example this smoothness level. I usually keep it at low because the higher the smoothness level, I would say the less the quality, because if you have some features that you need to show, and then this smooth will make like the surface so smooth. And then this optimization, I usually set it to high. For some reason this software doesn't show like when I click those buttons, but I think you know what I'm talking about. You just click that to high, and for example there is this fill the mark points and fill small holes. For example, it will fill these small holes, fill the mark points. The mark points would be filled, and then it will be like one part. You can see now in here, now we have this scan part, and then you can save that, of course. Now I'm saving this, but for some reason anything that I open while I'm recording this was not shown. So basically here I'm just saving this file. I'll show you in the just like after now I'll show you like what was going on. Now you can see that all the mark points are closed. My part looks great. I can save this one. I can save the mesh file. I click save and I'll show you how the process was done in a couple of seconds. Yes, so here there is also one option to go directly from here to GOM inspect. So from here I'll show you how to save it. You save project file and then place it somewhere. You can add a new folder. For example, now I'll just try 3D Academy, and then test 1 for example, and save it. Now I have saved the scanned file. Now I'm going to save this STL file, which we need for our work. We need it in the reverse engineering and for the inspection. And now I save this one as mesh file, and try to save it by the same name. For example, if you save your scanned your scanning work by test1, try to save also the mesh file in the STL format by the same name, test1, and then you will know like which one is which STL file is for which file. Then it will be easier for you to organize your work. Now if I double click that one, you can see our file in here, and also now you can open it in any other software, for example in Creo or in GOM.